The reason we need to seal these cracks on the concrete is because we would like to prevent moisture and oxygen to reach the steel reinforcement. The steel reinforcement is very important on a bridge deck, and actually is very important on any concrete component. So maintaining the steel reinforcement free of corrosion is extremely important. If corrosion reaches the steel reinforcement on the deck or in any other concrete component, the reinforcement itself is going to start getting affected by losing cross-section. Then it becomes weaker, and at the same time it cracks the concrete. Actually, the need for this research project came up based on investigation on some failures of materials used to seal cracks on previous projects. It just happens that when we were following up on the performance of some of the previous repairs, we noticed that some of the cracks that have been previously sealed using the material specified by the department were cracking inside the cracks, or new cracks were being generated. Therefore, there was a need for us to understand what was happening and what needed to be done in order to take corrective actions. We did try to repair some of these cracks on these steel girders using the same materials that we were using for concrete supported decks, and we found that that's where the problem was coming up. We did determine that the cracks that were failing, the crack seals that were failing, were more prominent on those decks being supported by steel girders. Therefore, we concentrated this research on steel girders only, because for decks supported with concrete girders, the materials that we have been using were satisfactory. As part of this project, our researchers developed a macro for a spreadsheet which actually can help us in determining how much movement we get out of these cracks on these decks over steel girders. On that part, with that particular program, we can enter different parameters for the bridge deck, which include, among others, the length of the span, the type of girders to use that were used on the bridge, the type of concrete mixes used on the bridge, and even the temperature conditions. Once we enter all those variables to better, such that we can better profile the particular deck, we can run the software, and that software is going to give us a prediction of what is the estimated movement of these cracks. From that estimated movement, we can actually identify the materials that are going to be suitable to provide a good long-term sealing of the cracks. These materials that we were able to identify now allow us to make some relatively changes to our standard specifications such that the problem will be taken care of.